So hello everyone, welcome to the next tutorial. In this tutorial, we are going to find the equivalent resistance RAB of this particular electrical network. Okay, so we need to find the resistance between these two terminals A and B. Okay, so as you can see, we cannot apply the folding symmetry over here. The reason for that is because it is not dividing this particular network into two equal parts. Okay, so we need to apply mirror symmetry. Okay, so let's say if we hypothetically assume a vertical line, okay, which is dividing this particular network into two equal parts and symmetric parts. So let's say the current flowing from this branch is your I1. Okay, so it means that the current flowing in its mirror branch will also be equal to I1. So this will also be equal to I1. Similarly, if the current flowing from this branch is your I2, it means that the current flowing from its mirror branch will also be equal to I2. Similarly, if this current is your I3, then this current will also be equal to I3. Okay. And similarly, if this current flowing from here is your I4, okay, then the current in its mirror branch will also be equal to I4. Okay, so we know one more thing, that if a branch coincides with this particular vertical plane, then the current flowing from that branch will be equal to 0. Okay, so the current flowing from this branch will be equal to 0 amperes. Okay, so it will work as a open circuit. Okay, so this will be the simplified version of this particular electrical network. Okay, so as you can see, these two resistors are connected in series and their combination is connected in parallel with this particular resistor. Okay, so it means that similarly these two resistors are also connected in series. So it means that on further simplifying this particular circuit, so it will be equal to R plus R in parallel with your R. So that will be equal to 2R by 3. Okay, so this will be your R, this will be R, this will be your 2R by 3, then R and your R. Okay, so the R equivalent or the equivalent resistance RAB will be equal to the parallel combination of 2R in parallel with your 2R plus 2R by 3 in parallel with your R. Okay, so on solving it, we are getting, so which is coming out to be your 8R by 15. Okay, so this will be the value of the equivalent resistance. Okay, let's solve the second problem. Okay, so in this problem also we need to find the equivalent resistance RAB, and the resistance of each branch is also equal to R. Okay, so in this case also we cannot apply horizontal plane of symmetry. Okay, so the reason for that is because this particular horizontal line is not dividing this network into two equal and mirror symmetric parts. So in this case also we will go with mirror symmetry. Okay, so let us assume a hypothetical vertical line or a vertical plane which is passing from like this, and it is dividing the network in two equal parts. Okay, so on applying mirror symmetry, since these three branches are coinciding with this particular line, so we can say that the current flowing from these branches will be, so I will be equal to 0 amperes. Similarly, I will be 0 amperes. Okay, so these branches will work as a open circuit. Similarly, let's say if the current flowing in this branch is your I1, so due to mirror symmetry, we can say that the current flowing in this branch will also be equal to I1. Similarly, if the current flowing in this branch is your I2, then we can say that the current flowing in this branch will also be equal to I2. Similarly, if this current is your I3, then in this branch the current will also be the current flowing will also be equal to I3. Okay, so this will be the simplified version of this particular electrical network. Okay, so now let's find as you can see, these two resistors are both connected in series. Similarly, these two resistors are also connected in series and their combination is connected in parallel. So the equivalent resistance R equivalent will be equal to 2R in parallel with 2R, which is coming out to be your R. Okay. Similarly, in this case also, the R equivalent will also be equal to R. Similarly, in this case also, R equivalent will be equal to R. Okay. So now this will be the simplified version of this particular network. Okay. So now it is very easy to find the equivalent resistance RAB. Okay. So as you can see, these three resistors are connected in series and their combination is connected in parallel with this particular resistor R. Okay. So we can say that let's say this particular resistance R1 will be equal to, so it will be equal to R1 will be equal to 3R in parallel with R. So that will be 3R over 4. Okay. Similarly, this particular resistor R1 is connected in series with these two resistors. Okay. So it means that the new resistor will be equal to, new resistance will be 3R by 4 plus 2R. So which is coming out to be your 11R by 4. Okay. So it means that this 11R by 4 is connected in parallel with this particular resistor R. So RAB will be equal to 11. So 11R upon 4 in parallel with R, which is equal to 11R4 into R over 15 R by 4, and that is coming out to be your 11R by 15. Okay. So the value of the equivalent resistance RAB will be equal to 11R by 15. Okay. So I hope it is clear how we are approaching. So that's all for today, guys. I will see you in the next tutorial.